Okay, the point of this video is how do I find the domain of a radical function or a rational function? That means a function that has a root in it or a function that has a fraction. So for ones that have a radical or a root, it needs to be an even root like square root or fourth root or sixth root, something even, because if you have an even root, you cannot have a negative number. Under the root sign, you can't root a negative number. So whatever's underneath that radical sign or root sign must be greater than 0. 0 or greater. For a fraction or a division problem, which is the same thing, you can't divide by 0. You can't have 0 at the bottom of a fraction. It doesn't work. So when you're looking at functions and you need to restrict the domain, look for radicals and look for fractions. Those are the two things you're looking for. Okay, so everything underneath this radical sign needs to be greater than or equal to 0. It needs to be not a negative number. Can't root a negative number. So let's just pick up everything that's under that root, set it equal greater than or equal to 0, and use our inverse operations to figure out what x must be greater than or equal to. Of course, 6/14 simplifies to 3/7, and there it is. Hey, this is a fraction or a division problem. Everything underneath that division bar, that fraction bar, it can be equal to 0. It can be anything but 0, because in math you cannot divide by 0 in the real number system. It's undefined. So we're going to factor out this denominator. Just using the factoring skills you already have. And we're going to set each factor unequal to 0. We're going to show that each factor is not equal to 0. So 2x minus 5 is not equal to 0, so x does not equal 5 halves. Because if x equaled 5 halves, then my denominator would be 0. And if x equaled -4, then my denominator would not be 0. Would be 0, and we do not want a 0 denominator. So you're basically asking yourself the question, what will make my denominator 0? That's the number we have to exclude. We have to get rid of the number that will make my denominator 0. Are there any values which would make the denominator 0? That's the question you're asking yourself. And in this case, it's 5 halves and -4, both of those values. All right, here's a big one because it has a root sign and it has a fraction or a division. We have to deal with both of those separately. First of all, what is underneath the radical cannot be negative. Now this is tricky the way they've worded this problem. It's not asking you what's included in the domain, which is basically all numbers greater than or equal to 0 are included in the domain. They're not asking what's included in the domain. They're asking what's excluded from the domain. Okay, so if those are the numbers, the ones greater than or equal to 0 that are included, then it stands to reason that the ones that would be excluded would be the ones that are less than 0. So the ones that are less than 0 are the ones that are excluded. That was kind of a trick question. But we do have to read them very carefully to make sure that we know what they're asking. Now let's go ahead and work on the denominator. The denominator cannot be 0. So we're going to take the whole denominator, x squared minus 5x plus 4, and we're going to say it cannot equal 0. Just like we did in the previous problem, we're going to factor it out. We're going to set each factor unequal to 0, and we're going to solve to figure out, again, the question is, what numbers are excluded, meaning what values would make my denominator 0. If there are any values that would make my denominator 0, those have to be excluded from my domain, which in this case is positive 4 and positive 1. Okay, so I hope this was helpful to you. Again, look for roots, look for fractions. When you're trying to exclude things from the domain, reach out if you have any questions. Stay safe, and I'll see you soon.